All right. So fundamentals of Python first, program second edition. Now we're gonna be dealing with theories at first and a little bit of history. Not too much, just a little bit. Um, you know, and then where's the laser tool? Laser filter. Here we go. Before that, the tool that we're gonna use. So what are we gonna be using? So I want you guys to install this one, Anaconda. Sorry. Here it is, anaconda.org. Sorry. All right, so this is where you wanna go. Okay, we're gonna be using Anaconda. So Anaconda is kind of like a collection of different apps, and then it has its own ecosystem of libraries. So we're gonna be using mainly this one. So you go to anaconda.org, go to download Anaconda. All right, so this is quite a large size, around 10 gig, I think. So make sure you have some space. You don't need to buy this one. It's completely free. You just need to, where's the download? Was it this one? It's change. All right, okay, wait. Okay, here it is. So you need to click here again and then go to free download and then Mm, okay, I haven't used this one. This is new. Let's see. Returning users. There's supposed to be a button here that you can just get directly without signing in. I did not sign in before. Just give me a moment. Hmm. I think I'm on a different. Or I think this one button will do it. Right, so it seems that they are requiring now a sign up, but you don't have to pay for this. But I'm still using Anaconda right now, so I'm sure that it's not requiring you to pay anything, but you need to sign up, like they're really requiring you to sign up. So, tamang products. Mm, all right. Okay, so that's what you need to do. Let's see. All right, let's see what we will do. Okay. So just go to the distribution part and then just choose Windows or Mac or Linux, depending on what you're using. But usually it's Windows. Mhm. Okay. So the download for this one is pretty straightforward. Just open up the exe file and then just keep on clicking next. There's no need to actually do anything special for the installation. All right. But this can take a while. Again, the size for this one is about 10. I'm not sure with the mini Conda. I haven't tried this one. We're using the full version one. All right. So yeah, just download that one in your free time, and hopefully by next week you should have that one, right? Because we're gonna be using that one until the end of our session. Okay. If somehow you don't have enough space for Anaconda, the alternative that we have is to use Google Colab. So just search for Google Colab. This is also free, but it's a bit slow, right? So Google Colab, and this is what that looks like. Just to confirm.
Hi, Daniel.
Yep.
I didn't quite catch how to download it because I was following on my other screen. So
Ah,
I
okay.
would need to sign up
Yeah,
with my email and then
unfortunately,
okay, and then
uh,
I'll be on the download page, right?
yeah. So you need
Okay,
to download
thank you.
Anaconda and then the one on the left, not the Miniconda. There are two versions of it. You already signed in. The Yeah, okay, this one, the one on the left. Just click on download here, or if you want to be specific, just click on Windows and then
Okay,
right.
okay, thank you.
No problem. And then where's Google Colab? Why is Google Colab not loading? Are there a lot of users today? Ah, okay, here it is. Just close this one. So this is basically what it looks like. If we say section, section, yeah, you're not looking right. So whenever you're using Google Colab, it will automatically save the file in your Google Drive. So you can just look at it at the um how do I say this, in the root drive. Okay. So from here, welcome to Colab, just go to File, then New Notebook and Drive. This is what it will give you. So this is technically what Jupyter Notebook also looks like. So I'm going to be loading it up later to compare it with you guys. So actually, let's start with Jupyter Notebook and then compare Google Colab with that one. Jupyter Notebook is something like this. When you're done installing Anaconda, there will be an option there where you can open something called the Anaconda Navigator. This is what you will use. As you can see, when you open that one up, there are a lot of apps here that you can use for different purposes, of course. But the one that we will be using is this one. Just look for Jupyter's book. Now, when you click on launch, the last active browser that you click All right, that is where Jupyter Notebook will open because this is a web-based platform. So if you click on launch and then I go back to my browser, it will appear there. So if I share the screen again to my browser here, all right, so this is where Jupyter Notebook loads up. As you can see, it loads up and takes a look at my drive, locally, my drive. So this is my computer here. So if I say like go to desktop and then look to this folder, data science, I'm gonna create your own batch here. So I'm gonna click on new folder. Let's say I'm gonna say batch 20, right? I'm gonna go in and then I'm gonna click on new Python. And this is now the Jupyter Notebook. So guys, as you can see, the look and feel is roughly the same, right? There's only a few differences. This one's at the sides. But the thing here in the middle and the controls at the top are mostly the same, all right? So this is what we call a cell, all right? Um, this is where you write code in the middle. So if I say something like print, which we'll learn what this is for later on, but it's very simple, right? So if you say print hello, it's gonna load up, and there's the output at the bottom. If you go to Jupyter Notebook here, so if you say the same line, okay, run the code, the output is immediate. The difference is because Jupyter Notebook is running in our device. Google Colab needs you to connect to a computer online, and then you're using that computer to process your program. So as you can see, there's a RAM and disk here, and if it's a check, then that means you're connected there. Again, I highly recommend you use the Jupyter Notebook from Anaconda because it's just much faster. It's easier to install libraries. And while you're using this one, you're kind of limited. But for the first few sessions, um, if you have no other option, then you can use this. All right. But yeah, I highly recommend you guys to install Anaconda and use Jupyter Notebook. Okay. All right. So if you have any questions with that, just raise your hand and let me know. For now, let's go back to our PowerPoint and discuss the first few parts. So yeah, you can go ahead and install Anaconda, and while we're waiting on that one, you can listen to this. All right. So mostly these are just um, things that we already know, but we're not going to be discussing everything on the slide. We're just going to be discussing the important parts, all right? So, what are the things that we're going to be needing here that we're also going to learn again in the future? So, algorithm. Algorithm is an important concept. This is like a recipe or a set of instructions. What many people don't realize is that we are making algorithms every day in our lives, right? So we are creating step by step of things that what we're gonna do, like how to clean the dishes. There's a first step, like wash, remove the leftovers, and then a pre-wash, and then put some soak it in water or in hot water if you want, and then wipe it with some sponge with some soap, and then rinse, and then put it out to dry. So those steps, right? So those steps with a very definite ending. That's what an algorithm is. Okay. Now, what just happens is that instead of doing it in our head or writing them out, the instructions, we're going to be using code. Okay. Now, um, processing is just from the name itself, we're just processing information. So when you say processing, that involves what? Manipulation, changing, transformations, those kinds of stuff, right? So we're going to be learning that as well. Okay, so here's an example of an algorithm. This is just for subtracting two numbers. Um, what you need, what's the difference between that? and an algorithm for computers is that you need to be precise, right? So if I say make a sandwich, so if your step is put a or make a peanut butter sandwich. So if your first step is to like get a peanut butter and put it on a sandwich. So odds are the robot will make a mistake because you need to be exact. You need to tell it precisely the very, very first step, like where the peanut butter is located, where the bread is located, how how many loaves of bread should you get, right? How deep, right? Should the robot get some peanut butter, right? You need to be exact with those things in order to be um like in order to produce the correct peanut butter sandwich. So that's the thing that you need to keep in mind when you're making algorithms. Let's see. Features of an algorithm. So yeah, if this is a finite number of instructions, yes. It's well defined, of course. You need to properly define it. Describes the process that eventually halts after arriving at a solution, yes, and then solves a general class of problems. So just because you can, what this means is that you have an algorithm for preparing a peanut butter sandwich. The same algorithm can be used to make a what cheese sandwich, a chocolate sandwich, ice cream sandwich. You know, um, just changing some of the inputs and then it can solve the same thing, right? Same problem. That's what we're trying to get with this features, right? So let's see. The common question usually from students is that what is the difference between an algorithm and a program? So again, an algorithm is more of a higher level, more close to the spoken language, right? And it just outlines in steps how to achieve a particular goal. The program, right, is the implementation of that algorithm. It's it's the application, right? How you transform those instructions into codes that the computer can understand, right? Because again, you and the computer, you're trying to communicate with the computer through programming, right? I mean, that's why it's called a programming language. You're trying to learn the language so that the computer can understand you, what you're trying to do. Just like learning any kind of language, Japanese, Korean, English, we learn grammar, we learn verbs, adverbs, we learn adjectives, right? We know how to use them. The same thing is happening with programming, right? We are learning what? Syntax, functions, data structures. It may sound fancy, but it basically is the same with how we learn. Uh, different languages, right? So yeah, it has no grammar, but it has syntax. It has no verbs, but it has functions. So those kinds of things, right? There's a question. Yes, Sir Michael. Yes, we have this is recorded and we'll be sharing it with you via LMS. Yes. So information processing. So information is commonly referred to as data because any kind of information, wherever it comes from, whether it comes from sensors, it comes from surveys, it comes from databases, right? You can refer to them as data, right? Even undiscovered things can be considered as data if you know where to look for them, right? Um, this is just very basic input, transform, and then output, but we can expand on that one. You can put somewhere over here storage if you want to store the information. And then in the ending part here, we can also put feedback if you want, to sort of like make the process more accurate. So if there's a feedback loop somewhere here that can tell whether the output is wrong or not, then it can improve the accuracy of our next results, right? Let's see, what else do we have here? So these are the other examples of where we can get data. So images, yep, the pixel data, music, the conversion of analog to digital, right? So it's become very, very precise these days that it's barely noticeable if an analog is compared to a digital copy, right? But others say it's still there, but I can't really discern it that much, all right? Because that's what we're still doing. We're converting analog, right, to digital, and then from digital to analog again. That's what we're doing with music. Even speech, the same thing with music and video. So it's just a series of images to be. Let's see. All right, so these is the basic of basics, hardware and software, right? I think we've all know this already, since high school, right? You can just skip this one. But if there is something that we need to take note of, it's that ports and net. So ports are like, my analogy for this one is doors. So you can treat ports as doors in your computer, all right? And that door allows to send and receive data, more like the endpoint of data, something like that. And then the network is like the highway where all the data travels, right? So that's a common analogy that we can use with networks, right? Um, so imagine if you have different services or application. Let's say you have a browser, that's a different port. Let's say you have another app like a calculator, that's a different port. You have Jupyter Notebook, that's a different port, right? So each application, each service requires a different port, right? If you want to communicate with a different device, that's a different port. So at first glance, it looks like there's a lot because um, it would seem that you need a lot of ports to communicate with other devices. But at first it was, but now it's condensed. More like there are fewer things that we need now to connect than before. Okay. We have RAM, also called internal, or the primary memory. We have the processor, secondary memory, right? So I'm not sure if all of you guys were able to remember these things. So we have the magnetic, semiconductor, and the optical. The optical is the CDs from before. I'm not sure. I think someone mentioned here earlier that they were below 20 United. So I'm not sure if you're familiar with what the optical is. Um, I asked a student before, do they know what a diskette is? So they don't actually know what a diskette is. And I told them that it's the same icon that you see on any app. And yeah, that's what a diskette is. And I don't know, it's pretty much the same thing, right? It's not changed even until now. Same icon. All right. What else? So this is just a representation of how memory works in your RAM. So you have different cells there, and it just stores a series of numbers, one and zero. But these are like each one you can say that each one is kind of like a switch, an on and off switch. So if it's on, that's one. If it's off, that's zero. And that's basically what the computer just needs, ones and zeros. Everything in our computer can be represented in ones and zeros. Every character, every number, every language on the earth can be represented by ones and zeros. Um, so we'll get to that as well. Just to touch on that topic a little bit. All right. What else do we have here? Machine code. Mm, All right. So we already know what the system software is to operate in the system. It's not really what we need right now. So this is more like just a review what we already know. High-level programming languages resemble English, and of all the programming languages, Python is the easiest to understand. Well, yes, that's definitely true from my experience. Python is the easiest. So yeah, our text editor. Yeah, so this is a kind of text editor, but let's see, it lacks some features, but it can also function as a text editor because you're editing some code. So yeah, we can also classify that as a text editor. Jupyter. The translator is the part that converts a program into an executable code. This is what the computer will run in order for it to work on your device, right? And it also checks for syntax errors, or in short, grammar errors, right? How you're using the different keywords and um, symbols in order to create your program, right? Let's see. What do you need? Swallow now. Let's see. All right, so this is just a short representation of how it's processed. We start at the text editor, high-level program. It converts that one into um, executable program, and then if there are any syntax, it will tell us this is going to the output. If not, then it will pass it directly to the runtime system. The runtime system there has control of everything. So that means we can now pass in user inputs and then it can also show outputs, right? So if, for example, you press W, right, and it will print out something in your app, then uh, that's an output you will see on your monitor, right? A brief history, right? So it's not really that brief. It started from way before 1800. Of course, we're not going to be dealing with that a lot. We're just going to breeze through it. Maybe some key parts only. Abacus, right? The first, considered as the first computer, right? Let's see. Calculator, Asian. Okay, this is the abacus. What's this? This is the Pascaline. Yeah, this is the Pascaline. Basically, it's just a calculator, but it's limited in operation. As you can see, there are only eight dials, so there's only eight numbers. Um, at that time, I think numbers didn't actually go bigger than eight digits. Range, of course. Again, it's only for eight dials. Operations, I think this was only for addition and subtraction. It couldn't do multiplication. Yeah, just addition and subtraction. What else? This was, if I remember correctly, this was very expensive before. And it needed specialized knowledge. So only those in the know-how can actually use this stuff, right? So it must have been amazing at um that time before when it would be amazing if something like this like automatically calculates for us different sums or differences, right? The same thing we can say for current technologies, right? Like if we say quantum computer, right? Quantum computers, not a lot of people yet know what a quantum computer is. And it's not yet available for um use for the masses, right? So it has it's in the same state as this one, the cost and availability. It's not really ready yet for use for the public. It needs a specialized knowledge as well. Limited range. Yes, we don't know what we can use it yet. Like we know what it's capable of. So it can process more bits than just the regular transistor. Transistor can just be in one and two, one and zero. Whereas, if you're using a quantum computer, you can pair that one with something else. I forgot. I'm not too sure with it yet, but from what I know, it can process more than two bits at the same time. So it will make calculations a lot faster. That's just what I know, right? This is the loom. Yep, the loom. Jacquard's loom. So I think this makes something like a cloth. Not really sure why this is included, but it must have used something at this part. So I'm not really sure about the loom. All right, let's go now to Charles Babbage. This is the analytical engine. Herman Hollerith, the EBM. Boolean logic is George Boole, and then Alan Turing. Yes. Foundations and limits of algorithms and computations. Okay. So Boolean here, Boolean logic. I think some of you guys, depending on which school you go to, they teach Boolean logic to high schoolers. So it's actually pretty simple. I think you've heard of this one. The and, the or operator, the NAND, the NOR, XOR, XNOR. So if you guys remember that one, it's usually used for fallacies or disproving of statements, something like that. So I'm not really that well versed with it, but we had a subject like that before. This can also be used in processing data because again you're dealing with ones and zeros, but that would be at the lowest level, like at the assembly language level. So we're not going to be going into that. It's very hard. I've tried it before. It's very hard. It's very error prone, and it's not really practical. So it's really a advantage, right? That we have programming languages nowadays. It just makes things easier for us because that program will be converted to the equivalent of its assembly language equivalent, ones and zeros, the executable part, and then that is the thing that the computer understands, right? So now we are communicating with the computer, with that program, right? So the first electronic age, let's see, switching circuits, 1940s, these is the time for, um, this was around World War II, right? Mark One, ENIAC, ABC, first memory stored programs, mainframe computers at this time were very big. They were very big, mainly because they were using um, vacuum tubes. Okay, so again, it filled entire rooms. The change came in when the transistor was invented. So it's the same thing as the vacuum tube, but at a smaller package. And the price is also a bit cheaper. So from the inception of the transistor, that is when things started to get smaller and smaller and smaller until we have a device in our pocket that is already very powerful enough that we can use almost all of its features, all of its capabilities, right? Because there was one comparison where our modern phones are is actually much more powerful than the entire computer system from the first um launch of the spaceship, I think. So I read that somewhere before. I'm not really sure if it's true, but if it is, then I'm not really surprised. So let's see. Assembly languages, yep, it had very simple instructions like add and output. Assembler, let's see. Mnemonic codes. All right, so high-level programming. These were one of the first programming languages available. So Fortran, Lisp, and COBOL. If you guys are familiar with this, um, that's good. So this is fairly old. It's very old. I'm not sure. I think there are still some who are using this one mainly because they can't switch to a new one because it would be more costly for them if you were to switch directly to a different source rather than just continuing with it and looking for someone that knows the language, right? Common feature is abstraction. So what is abstraction? This is actually a very important concept. This refers to the practice of simplifying complex operations or concepts uh, by providing something of a higher level. So that is what we get here, the programming language. So what is being abstracted? The assembly language is being abstracted by the high level programming language. So an analogy for this one is that um, how do I say this? Let's say you're driving a car, right? This is my analogy that I use always with those students. So abstraction. Let's say you're driving a car. What do you do with it, right? So you know how to drive it, but do you have any idea how it works internally? Like, um, how about the engine? What kind of engine is it used? How many uh like CCs it have? Um, what other features that it has? Is it automatic? Is it manual? But do you really care, right? You just want to use the car to go from point A to point B. So that is abstraction, right? They provide you with enough things, enough inputs that you can use uh that can allow you to drive the car from point A to point B. They don't require you anymore to know the internal things of the engine. Just the basic things like maintenance, the oil, gas, right? So the main thing here is that it's more focused on usage, right? So steering, it's literally braking, traffic rules, right? So you're not anymore burdened by the technical details of the car. That's what abstraction is, removing the complexity. So yeah, too much abstraction is also a bad thing. So just go at the appropriate level. If it's too much abstraction, then you will reach a point where the original idea is gone. The original idea is not anymore visible, right? So you'll have a difficulty trying to understand what they meant, right? So let's say, for example, you have an apple, right? If you were to abstract an apple, what would you say? you would say fruit, right? Fruit is at a higher level. An apple is a fruit. So you can still kind of see, right, how it's related to apple. But if you abstract it even more, right? If you abstract fruit even more, and I say nutrition, so it would be very difficult to relate the single concept of the apple to the thing nutrition because now they're too far off. There's a lot of things that can be considered as nutrition. How will it like focus on that specific part only? So that's the thing that you should avoid, right? Too much abstraction. Okay. And 1950s vacuum tube gave way to British sister. This is a solid state device. And with the transistor, you start developing an integrated circuit, right? So basically, you can think of this as more like mini computers, right? They evolved somewhere around 2000s, I think, from here to mini computers. All right, so Engelbart, we have the mouse, Altair, the first microcomputer, Intel's 8080. So seeing the word is microcomputer. What else? We have MS-DOS from 1980s. If you've ever used like MS-DOS, it's actually fairly difficult, but it was quite a hit back then. A lot of um, private and public, private business owners use MS-DOS, especially Excel at that time. So, was I able to use it? Yes, but I was still a kid back then. But I know what MS-DOS looks like and the annoyances that comes with it. So, if I remember correctly, it doesn't notify you if you have saved the file. So, if you shut down the program and you forgot to save the file, then it's goodbye to your hard work. Also, they were using diskettes, floppy disks at the time, and they were very fragile. So if you happen to drop one or like scratch the film a little bit, then your data is gone. It will not be read anymore. So yeah, nowadays we just upload something and then download it directly to the other end, right? Or using USBs. But even the USBs are starting to die out, mainly because we have everything now on the internet, right? And after that, Bob here created the Ethernet used in LANs. And the primary purpose for this one before was just to connect the computers that they have at their location, right? So it was intranet, that we call intranet, because it's just for them. But from that, they decided, hey, maybe we're going to connect to the other side of the state. And that's when that concept started. So it became ARPANET, and then it moved to something we call internet nowadays. So yeah, if you're looking for like, let's see, um, Ethernet. So other alternatives for passing data, right? We have Wi-Fi, we have Bluetooth. We also have PoE, so that's power over Ethernet. So imagine you have an internet cable. There's also a power line going with that together with it. There's also the opposite. That's Ethernet over power. So that means you have one plug here, another plug in a different part of your house, and the Ethernet data is shared among the two. So you can use this one if there's no connection from one end of your house to the other end without using a wire. It'll just be using the internal wirings of your house, so to speak. So that's Ethernet or power. This is also what you see, I think, for oh no wait, for cameras, for VoIP cameras, right? The CCTVs. Usually what you see there is just one line, and then there's nothing there where um the CCTV is being plugged in. That's because the power comes with the internet line, right? So now you know when you're looking at one and there's just one line, that means the power comes from that one line. Okay, let's see. So now we have virtual reality. So we have a lot of things nowadays. And we will have 4D entertainments like in parks and amusement parks. Next is what we have here. Hypermedia. We have HTTP, Hypertext Transfer Protocol, and Hypertext Markup language. HTML is not technically a programming language because you're not really making a program. You're just making a structure of your website. All right. Now, HTML is considered as the backbone of any website. So when you say that you're developing the HTML, you're just developing the backbone of your website where everything else is being attached to. That's what the HTML is used for. And then finally, we have the components of the World Wide Web. We have web servers, browsers, and clients. All right, now the client here is our device. The browser is whatever browser you're using, and the server is any kind of computer that is serving out uh, websites, right? So this can be any kind of computer, any kind of laptop. They can be served as servers. Now, will they be powerful enough? That is the question, because specific um, there are specific products that can be it's more accurate, it's more reliable if you were to use them as servers, right? Even there are even motherboards that are for server use. So, okay. Let's see. Communication, presentation, and income. So web application, yes, we finally arrived to the early millennium. So web apps, this is the time when Netscape was invented, where Yahoo was invented. We didn't have Messenger then, but we did have AOL. We have GeoCities. We have Alta Vista. We didn't have Google back then, so we have to use Alta Vista or Ask Jeeves, if you guys remember that. So this is the advent of most of the web apps that we have. And then around like, let's say 1995, I think that was eBay. So that was when eBay was discovered. Here, Sergey and Larry developed algorithms for indexing and searching the web. So these algorithms now, right? These two actually created Google, right? And the rest is history. So Google is now the largest search engine currently. So let's see what else do we have here. Mm, PDAs, so I haven't really used PDAs. I haven't seen one, but what I do know is that they were essential when you need to like contact a person and then uh, have them come running. So usually what we see in shows is this is commonly used by doctors, PDAs, for my, so, but it can be used by anyone, really. Next is we have, of course, Steve Jobs. Created simple key devices, namely the iPod, iPhone, and the iPad. So they're very iconic even until today, right? Social networking, yes. The very first social networking that I know of was Six Degrees. That was around 1987. Next is around 2002 comes out Friendster. And then around 2003 was LinkedIn. Um, 2003 was MySpace. So MySpace had a lot of freedom with creativity. So unlike Facebook nowadays, where there's a lot of limits and precautions, right, with pages. All right. Big data technology where government, business, and hackers completely monitor internet traffic. So big data, again, can come from a lot of different sources. Geospatial, weather. We also have video, images, text, those kinds of things. All right. And then finally, we're also invented the Python programming language. So Python is a high-level general purpose programming language for solving problems on modern computers, right? So basically, uh, let's see. Aside from Python, we have C++, right? C Sharp, we have JavaScript, we have other languages now that are offshoots of this, right? Like they're using the same code base, but they added some new things and then call it something else, right? Like Roblox, for example, they're using the language something called Lua, but it's actually an offshoot or a somehow similar copy of C++, right? They just added some more things, I think, in order to make it their own. What else? After this, oh yeah, one of the common questions I have is that why is Python the one that's usually used for data science? So my answer to that is it's not really because it's Python, it's because the ones that developed it earlier were more proficient in Python, so they decided to, hey, let's make this in Python, something like that. So if the question again is, can I use other languages? Yes, there are some libraries in other languages that you can do the same thing with Python, and that is for data science. So they have their own thing as well. Let's see. All right, so this is the shell. Mainly this is how we communicate with the computer. So a direct connection from us as the user to the device, right? That's what the shell is for. Um, let's see. All right, I think that's all I can say with the shell. We're not going to be using the shell. We're just going to be using Jupyter Notebook all throughout. Okay, and there we have it. Okay, so that's actually the first half of our discussion. So as you can see, not really that complex yet. Just a short review of what we should already know and what to expect in the future. Okay, so again, we're going to be starting at the very basics of Python. We're going to go slow, but not too slow, right? Just enough so that the ones with no background yet in programming can easily follow. All right. Any questions so far before we uh, proceed? All right. So no questions. That's good. That means if this was a class and I would have a quiz, everybody would get perfect, right? So yeah, since there are no questions, it should be very easy for you guys. All right. The next part is we're gonna be dealing with code. So of course I'm gonna be using Jupyter Notebook, but in this case I'll also be using the other one, Google Colab, just for you guys to see um, what the output should look like if you're using Google. Okay. Um, let's see what else. There are some buttons here that you can put. So if it's this one, then it will add a cell at the top of the current one, like this. If you click on this button, it will add a new cell below the current one. See? So up, down, yeah, I think that's it for now. Um, right. Oh, okay, that's question nine. So let's have a quick break. 15 minute break, you know, since I've been talking for quite a while. Let's have a quick break, a water break around 15 minutes. I want you guys here to be back by around it's 2:37, 45, around 2:50. I think that's good enough. 2:50, and we'll continue with the next lesson. Okay?
Okay.
Great. So don't leave the room. Okay? I'll just turn off my mic and video. Everyone's back and had a good break. So I actually went a bit over time, about 8 minutes. Uh, that's okay. Let's see. Can I get a thumbs up just to know that you guys are here? Okay, one, two, three, four, five. All right. Okay. So let's start with um Python, right? Let's see. So let's see. Programs usually accepts inputs from a source, processes them, and then output results to a destination. So inputs depends really on the program that you are using. So the inputs can be uh clicks, keyboards, or it can be uh from different sensors. That can be an input as well. And then it's processed depending on the program and then output to a destination. Now, our output here right now is just our monitor. So it will be displayed on our monitor. And for data scientists, that's usually where we will just see our output. Usually in um, a visual representation like charts or graphs. So then be using that. Um, let's see. Shell, again, we're not going to be using shell. And then force output available using the print function. So this is our first thing that we're going to learn in Python. It is the print function. Now, let's start with the word function. Now, what is a function? Now, by the word itself, function, right? Like, what does it do? Okay. When you say a function, what's the function of a pen? The function of a pen is not to write, it's what we use it for, but the function of the pen is when you push it down on something, it dispenses ink. Right? That's the main function of the pen. The pen itself does not write. We are the ones writing with it. So we are the input. The output is it just dispenses ink, right? But the way that we move the pen, right, it has created text, right, words from that. So that's what we know as function. But in programming terms, a function it is a self-contained block of code, right? So imagine that print here is a code, right? It is a block of code that we don't see, right? And what is that something that we don't see, right? Probably it's something complex, right? And what do we call that? It's abstraction. A function is a form of abstraction. So we don't see the code, but we know how to use it. At least that's what we're trying to learn here, right? So functions are an abstraction, and we use them to organize and modularize code, uh, make it more manageable, so to speak. What else? It makes it more reusable and easier to understand. So if you were to know the exact code of print, right, it would be very complex at this point in time. But we do know the word print, right? Because print, I think everyone has used a printer before. It will just show us, right, and on the paper what we wrote on the document, right? So that's exactly what we also see here. But instead of the paper, we see it on the output section here, monitor, and also here at this part, right? What else? So what did I say earlier? We make it reusable, right? Because if that same code, right, if you were to repeat the same code over and over again, just to have the same kind of output, then it would be redundant, right? Like you would have a lot of lines here. Sorry, where did it go? Um, Is it okay? I think there's something wrong with my Jupyter. Let me launch it again. So as you can see here, localhost 889. So that is the port 8889. All right, it's connecting to that port. And then hopefully, yep, it can connect to here. So desktop, let's just look for your batch. What's this? I'll just be calling this one batch 20 notes. I'll also be uploading this one on the LMS for you guys to review as well. So reusable, right? What else? Manageable is similar to reusable, right? Because there's a lot fewer codes that you're going to be using. Modularized. So that means if the function is contained, right? That means you can just copy and paste that one or import it to somewhere else where it can be used directly, right? So if different parts or a coworker, for example, were to use that function, then you can just import that function. So that is in the form of copy paste or using an import keyword, depending on what you're going to be doing. But the point is that it can be easily transferred. That's what modularized is. And yeah, if you can follow those things, then it's basically a way of organizing your code, right? But the function itself here is print. That's the name of the function. Usually in text editors, they give out different colors for a function. So here it's slightly yellow. Here it's a green, right? So they do this so that you can identify which one is a function if it recognizes it as a function, right? So that means that word, you cannot use that word for anything else. You can use it as an output here, part of an output, but you cannot use that word for anything else. So if you were to create another function, you cannot use the same name. It's basically reserved. So that's what it means, okay? And you can see the hello here is also color coded. So this is a string, a data type, which we will discuss again. First is what should we discuss first? So since we're learning functions, right? We know abstractions. We know that it hides the complexity. So what do we do with those things? We use them, right? So we haven't learned how to use them yet. Uh, let's see. Okay, can I wait for a minute? The chat here. All right. For your case, Sir Gavin, if any of you guys have Python installed before in your systems, right? You will see some checkboxes. Um, can you also share these screenshots, sir, to everyone? Can you share? Can you actually share it to everyone? Everyone, okay, so that everyone can also see.
Paano, sir?
I think you can just send it again to let's see, save as. I'll try to send
Ah,
it again.
okay.
Let's mhm. So this is what Sir Gavin is looking at when he installed um Anaconda earlier. So if you install Anaconda, it will also install Python for you. So if you're gonna be asked this question, um just put a check mark on all the checkboxes. So add Anaconda 3 to my path, register Anaconda 3, and then clear package cache. So it's perfectly fine if you check all of those things. The old one would still be there. So if you have apps that are using that old one, it will not modify that in any way. Okay. It will still be there and your apps will still work. What makes Anaconda great is that it isolates itself from all the other Python versions that you have. So this is kind of like what you should always do with Python. You need to isolate something whenever you're creating a program. Before it was actually kind of a hassle when you always develop something in Python, but with Anaconda you can just do this automatically because it isolates itself from your system. So it doesn't care what Python you have before all your apps will still work. Okay, so if you were to install Python manually, then you would have to do a lot of other extra edits to your system, um which is all right, but it's a bit time consuming. Anaconda just simplifies everything and packages it into its own separate thing. It doesn't mess with what you have. So your apps will still work, so don't worry. Again, just check all those boxes when you're installing, and then it should be good to go. All right. Oh, by the way, if you guys have any questions, just call my attention, and I'll try to see if I can answer it. All right. Let's see. Where were we? So functions, right? We're gonna try and use a function. The basic syntax for functions in Python is that you start with the name of the function, so that's print, right? Next is you follow it with open and close parentheses, and then the ones inside are what we call your inputs to the function, right? So these are the inputs to your function, right? It's the same thing here. So the syntax is roughly the same. So we're going to be discussing about this one later on. So any kind of function, that is always the format that it will use. Now, you can have as many inputs as you want, but it depends on the function, right? Because if you were to read a function, right? At this point, we're gonna take a while because if you really understand, right, how to read a function, it will make things a lot simpler later when you try and search and understand other functions later on. So the way that I do this is that how do we learn, right? How to use a function, right? Because when we learn how to drive, you go to a driving school. So in programming, what we do is we go to the documentation. So you go to python.org. And there's a handy little search box here. And you can see that there's a history here. Go print. Just search for it. It's not really here. Let's see. Here it is. Documentation. So click on documentation, and then this is part of your work actually. You're gonna have to go to the website of what library or program language you're using, and then search, the different functions that's there. Let's see. Python docs. All right. So what version am I using? What version am I using? So this is, let's see. Mm, Sorry. Settings, help, there's help. Oh, there's even the reference here. Python reference. Let's see. Okay, it's the same thing. It's the same thing. So there's a shortcut actually here, settings, and then go to, it's in the help and then Python reference. There's even some references for the most commonly used libraries here. So you can just go directly there. But Python reference. Okay, so it took us to 3.12.12. This is 3.14. All right, so there are different versions. So Anaconda is using 0.12.12. That's okay. It doesn't matter that if it's a little bit late because usually the development of languages has different versions, right? So this one is in the development stage. These are a bit advanced, but 12.12 I think is the most stable one. That's why they're using this. So there might be functions in 14 that are not in here. So whenever you're searching for code, make sure that you're using the same version, right? But as long as the first number is the same, odds are there the differences are not that much. This is usually for security purposes. This is usually for minor adjustments your to the programming language, not really major adjustments. Now, if someone was using version 2 and then you're using version 3, then it's an entirely different thing. Okay? As long as the first number is the same, it doesn't matter what the ends are. Again, this is just for security and then minor adjustments. This is the most important one. Okay, version 3. All right, so we're going to be using this one, 0.12.12, and then there's a handy search here. You can just search for print. Make sure to also include the open and close parentheses. Um, Enter. All right. So, um, print actually comes in with Python. So it's built in to Python when it was installed. So it is also called a built-in function. One of the built-in functions in Python. But you can try and see the others here. So this is print 2 to 3 fixer, Python 2 to 3 code transition. So this is what you use if you are from Python to the Python 3. This is pprint, so this is a different library. So that means this is what we're using, print. Okay, so it's up to you guys to actually, uh, I forgot the word, analyze, right? The different options that we're gonna see. Okay, so other libraries have fewer like search points. Where basically print is actually a pretty big word. There's a lot of things that are related to print. So let's see. Okay, built-in function. Okay, here it is. So as you can see, this is print. This is the syntax that you're gonna see. Okay, this is what you need to learn in order to use the print function. Now, what you will see here are the inputs, right? And as you can see, there are four. 1, 2, 3, 4, and 5. All right. Each is separated by a comma. So you see, comma, comma, comma. Now, the rule of thumb is that you follow the same sequence when you're using it as well. So first is objects. Let's understand this one. It says print objects in a text stream file. We don't know what that is. Separated by sep, followed by end, sep, and file and flush. if present must be given as keyword argument. So that's another thing that we have to learn. So there's a lot of words here that are very confusing, right? Um, all non-keyword arguments are converted to strings like string, does, and written to the stream. Um, both except and end must be strings. They can also be none, which means to use the default values. So this essentially means that if you don't declare them, you can just leave them as is. That means this can work. Even though we did not declare those other inputs, it will automatically use the default values. We'll just go into that later. All right. If no objects are given, it will just write n, whatever n is. This one. The file must be an object write method if not present or none. This is actually not used a lot. And then flush is also for buffering purposes here, stated here, but it's not really that used that much. So usually we just use these three inputs, right? So it's very confusing, right? Reading it directly from the documentation. There are other sites available in Google. You can just go search it. Parent function Python. Usually this is the one that comes up first. It's from W3 schools. And this has a much simpler way of explaining the syntax. So it says objects. I think this is zoom out, sorry. It says objects, and any object and as many as you like will be converted to string before printed. So at this point, we don't know what string is, right? We'll discuss that one later. That's a data type. But it says as many as you like. So we know that this is considered as an object right now. So that's, I think I'll do it here. Uh, okay, Markdown. Don't be confused with this one. I'm just using Markdown for readability purposes. It's not really a language, more like it's text formatting. You'll see what I mean. So um, if I say, what, I'll put this one as notes. If I say, right, data types, right? So we know now that there is one, and that is strings. What else? We also know objects, right? We'll put that. What are objects? So this is what I usually do whenever I'm trying to learn something. I put out all the words that I don't know and then define them later on and try to see if I can connect them. As I go on, keyword arguments. Right. As far as I know, the hardest part in learning different languages and their functions is the syntax because they look something like this. So it has a bunch of words that are really like alien to us, right? Unfortunately, that's what you have to do. You have to get used with the lingo in order for you to understand what you're using. All right. You don't have to understand everything in one go. Just put them out somewhere that these are things that you have to understand at some point in time. All right. And what else do we have here? Sep it with an equal sign and separator. Specific how to separate the objects. Default is uh blank. So this is just to print two single quotes, yeah. And optional. So the keyword here is optional. You can or cannot put them. Specify what to print at the end. Default is slash n or line feed. So we call this line feed. What is a line feed? put that here. Of course, you're gonna use Google with this, but I'll just put it here. File option, an object with the file mode before this, system.stdl. Basically, this is your monitor. Flush to buffer default is false. Nothing really we need right here for now. So we can just skip that one. All right. So, or you can put this one in your list as something that you need to learn. That what is flush? Why do we need to buffer something? And why do we need to flush them out? So there's a specific reason for that. All right, so let's go back here. Strings. How do you define strings? Strings are anything that is that you want to be represented as characters. All right. So if you want numbers to act like they're just regular text, not numbers. So if you were to add 5 and 5 as regular numbers, you would get 10. But if they were strings, you would get 55 because they are just treated as characters. They are not treated as numbers, right? Um, on that note, the second data type that we can discuss is numbers, right? So if you have strings, you have numbers. So these range from any kind of number, integers, floating points, right? That you can consider as numbers, and you can use with mathematical mathematical operations. All right. So at this point, you can use mathematical operations. How do you represent strings? You represent strings using double quotes or single quotes. That's what you do. And that's why we have here for hello, we have double quotes at the end. Okay. You can use also single quotes. Doesn't really matter. Um, Python will recognize that. All right. With numbers, then just use numbers directly. Okay. So regular wants you really 4, 5. Again, you can also represent a number as a string. So this is a string of 1. This is a string of 2. This is a string of 3, string of 4. So if you were to like say, um, let me see commas here. So basically, I'm using semicolons here to separate each point. So basically, if I were to say add, right? If you were to add 1 and a string of 2, what you would get is 12, a string 12. But if you were to use numbers data type, um, what you would get is 1 plus 2. What you would get is 3. You can perform mathematical operations on that one. All right. By that note, so what is a data type, right? So from the name itself, what type of data do you have? So you have a string, I have a number, but something more simpler. Let's imagine we have a box, right? We have a box, and let's say that box is for kitchen utensils, right? You put a label there that this is just for kitchen utensils. So when you get like a fork, you put it on a box. You get a spoon, you put it on a box. But if I say get a stapler, right, that doesn't belong in the kitchen utensils, it does not fit with that box, right? So you're kind of like labeling the things that can fit inside that box. And that's essentially what data types are for. You're kind of separating the different things, the different data that you can process. So you separate the strings, you separate the numbers, because that means for numbers, then you can use mathematical operations. If it's for strings, then you can use other operations on that one. Like for this, we call this one string concatenation. 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 Got it. Sure. There you go. So it's the combination of two strings. And we can actually see this one in practice. So if you say print, right? And then you say 1 plus 2, what you get is 3. See, it even performs the mathematical operation, right? Now, if you say print and then string 1 and then plus string of 2, what you would get is 12. See? So this is how string concatenation works. So you're adding two strings, it will be processed as characters, and they are combined as characters. So that's what you get 12. Here, they are added first as numbers, and then printed out in the output as a string. Remember, it did not define here. It is defined here. So it will be converted to string before printed. So if it's any kind of data type, it will be converted first to string before being printed out. So the one that you see here on the output, okay, this is already in a string data type. Okay. So you might be having a question, sir, are there other data types? Yes, there are a lot of data types. And yes, you can create your own data type. So let me put that here. You can create your own data type. And this is where things get confusing when you get to libraries. Because when you get to libraries, right, session 4, session 5, they have their own data types. They create their own data types. So um, if you don't have this one understood by then, uh, you might need to review something or watch some additional lessons or some exercises just to get your head around what data types are. Okay, because at first I remember when I was learning this one, it was very confusing when I got to libraries because they don't really explain anymore that it's a new data type. They just assume that we know what a data type is. So something like that. Um, they're kind of assuming that you know what you're doing already. And they don't do simpler explanations anymore. They just skip directly that this is what we have, this is what you do with it. They literally skip the part where this is our data type. This is what you use. So okay, this is a question. Variables related to libraries. Actually, variables are related to everything, so we'll get to this one later, so don't worry. Right now we're not using variables, but I think it's in the next few slides, so we'll get to that. All right. Let's see. That's another thing, right? We need to put that one here. So as we go along with our lessons, we'll keep on going back to this list. Libraries and variables. There's a lot of words here that we don't know yet, right? But that's okay. We'll just fill them out one by one. Okay. Apologies for that. Um, so where do we go now? So we know that we have numbers and string data types. So we'll stick to that for now. Just the two basic ones for now. Right. So by definition, we are still at the objects, right? Objects. So, as any object and as many as you like. So, if we go back here, and I think I'm just gonna close this one. I keep on getting confused with this. Close, close. All right, close this one. Close this one. Good. All right. Okay. So objects, right? It says any object and as many as you like. So from that um state, right? And from the statement here, create objects to start the text string file. That means, okay, everything that's written here is the same here, but it's just in a more, how do I say this, in a friendly format, right? But if you want the complete one, this is always better. The one from the documentation, all right? And for me, I think it's better if you get used to the original documentation because not all have something like this, right? They have this because Python is very famous. If you're into like other libraries, they don't have something like this. So you're gonna be stuck with this one, a lot of text. Object. So that means the string here is an object, right? Because it accepts that one. That means this is also an object. This is also an object, right? So it considers that one as an object. So for now, um, in order to avoid confusion, what I usually say to my students is that treat everything in Python as an object for now, just to avoid confusion and you don't get too overloaded with information, right? So yeah, treat everything in Python as an object. So, all right, so we know that this is an object, a string is an object, a number is an object. Then as many as you like. So we know that you need to separate them by commas, right? But it doesn't really say how. It just says object with objects and then comma. But um this is an examples here. So this one doesn't actually have examples. So by my standard, this is something that's not good for a documentation. They should have examples. But luckily for us, there are some examples here on how to use it. So you can see here, you can separate them by commas like this. So we'll try that one out here as well. Okay. Okay, so if I were to say print and then uh hello again, and then comma, and then let's try 1 and 2. So 1 and 2, right? And then the string 3 and 4. What would be the output? If I were to try this one, this is the output. Hello, 3, and then 3, 4. So hello here is just processed directly because it's a string already. 1 and 2, it has to evaluate this one first. It has to know what 1 and 2 is first. 1 plus 2 before it's converted to string. And then this one, Python will have to evaluate this one first because there's an operation in between. And so it's the result is actually 3, 4, the string 3, 4. So in any part of the function, if there is a uh, operation inside, Python will automatically process that one first before uh, passing it to the print function as an input, right? So before passing it as an input, Python processes that one first, and then what will happen is to Python, right? Up to the print function, what this would look like is something like this. It would look something like this already. All right. So it won't look something like this. It will look something like this to the print function. Okay. So Python evaluates this one first, makes it more simpler. It becomes this one. And then now this is the data that is passed to the print function. Okay. These are the inputs that you pass to the print function. All right. What else? Oh yeah, this one. This is actually called a comment. So a comment is all right. So there are two uses for a comment. You can use this one to write notes on your program. And this is actually very important whenever you try to create your program because in the end, odds are you're not going to be the only one doing the work. You're going to be in a team. And when you're in a team, it's always important to communicate. And the way that programmers communicate is by writing good comments, right? So what is a good comment? Not necessarily that you have to explain each code, more like what was going through your mind when you were creating that code, and a brief description of what your code will do, especially if that code is 100 lines long. So they need like a summarized version of what it will do. Unless there is something wrong with your code, there's actually no need to go too deep into that um, until the cybersecurity department comes in. So it's their part to take a look at each code and make sure that there's no like loopholes or something. But that's not your problem. Um, so yeah, I use this one to write notes in a program. Another use is to skip parts of the code. So whenever you have a code and that is preceded with this one, the number sign, uses the number. So that means that that line is a comment. So if I were to print this one out, as you can see, it only processes this line, not this one. If I were to remove this, uh, what is happening in keyboard? There you go. If I were to remove that one, and then run the program, you will see that it has two outputs, right? So I'm only adding this one here just to show you what data is actually being passed to the print machine. Okay, right. Our questions so far. What else? Let's see. All right, so let's go now to the next one, the set. So, oh yeah, there's another word here, parameter. We'll put that one here. So parameter, and then what goes with parameter is arguments. So let's see. Right, earlier I said that these were the inputs, right? But the technical term that we use for them are parameters at function definition. So let's see. We'll expand parameter more later on when we are creating our own function. Right now, just focus that these are your inputs. You can't really relate parameter with each one until you also understand what arguments are. These two go hand in hand. For now, just understand that these are our inputs, right? So the next one is a separator. So how does it know that we are at this point? Of course, we're going to be declaring sep, right? It even has an example here. Sep is equals to separator, and then the default is um, blank. So a blank one. So what does this do? Specify how to separate the objects. So if we were to take a look at our previous outputs, right? This one. These has three objects, right? One, two, and three. There are three objects. So our step here is what? By default is blank. So that means each object has a blank in between. That's what we see here. Blank, blank. See, that's what we see here. It's already in effect. The step is already in effect. We just didn't need to declare it because we already like the default option, which is blank. But if you want to change that one, right, all you have to do is add a comma and indicate that you are now at the sep part of it. So sep and then equal. If you want to assign a new value to a parameter or to an input, you have to use an equal sign. And then in this case, it is stating properly in the example that it must be a string. See the quotes, the single quotes. It's even stated here. Let's see. Um, both sep and end must be strings. See? So we need to use strings here. It's not really indicated in the um at this point, specify what to print, specify if there's no default. It doesn't really specify it needs to be a string. See? So there is information missing in this summary. So in here, it's much more complete. Both sep and end must be strings. So you guys already know what a string is, right? So if we say I want them to be separated by, how about colons, four colons, something like that. So if I were to run the program, that will happen. Okay, it will be separated by four colons each. Now the same concept applies with the end. Now the end is, of course, from the name itself, how it will end the function or the output. Specify what to print at the end. So the default is slash n line feed. So we have that one here, right? Line feed. So that means what does it actually do? Right? So let's observe this one first. Let's remove this one. Right, and run the code. So we have this first, and then this one afterwards. So what do you see is happening? After the first query statement, the output goes down to the next line and can start the second line, right? So technically, that's what the slash n is doing. It's going to the next line. The line feed here, this is a call out to the typewriter age where after typing out, right, if you ever have used a typewriter, right, you type something and then it registers the end and it says ding, and then you have to put the carriage return to the beginning, and then it automatically goes up the next line. That's a line feed. So I don't know if you can imagine that one, but um, so when it goes back, when the carriage returns, that's the enter key, by the way, carriage return. When it goes back, it the letter goes or the paper goes up one line. So it goes to the next line, and that's the line fee. So this is equivalent equivalent to pressing the enter key on your keyboard. So just imagine that one. Okay? Just to avoid, you know, on your keyboard. Just imagine that one. You're pressing the enter key at the end of this line. So you're typing this one out and then enter. Then we go to the next line and then enter again. But what if we were to change that? So I were to change and I say it will say end, the word end. So if I were to enter and run this code, it will say hello before end, see the word end, and it will proceed directly to the next code. This is this one, right? And afterward, it will go back to the next line. So if we were to copy and paste this code and go and do this one again, you'll see that after here, the second line of code, it will go directly now to the next line because the end here is still the line feed, the slash end. So this is the slash end, small. Okay. So you might be asking questions. Are there other code that we can use for /n mode? Are there any other equivalents? So I don't have them in my head, but I think /t was for tab. Yeah, okay, that's a tab. Um, Forgot the others, but let's see. I think we can do quick Google search for this /n/t. Okay, hey, let's put some Python for now. License titles for escape characters. This is what they're called. Escape characters in Python. Thanks. There's some AI. Oh yeah, here's a good output here. I can't really read it properly, but it says, oh yeah, /n is a new line, T is a tab, S is for, oh no wait, this is an escape character for a single quote, escape character for a double quote. This is for a double slash. Um, or carriage returns, so line one, carriage return, line two. So this is the regular carriage return. There's no line feed. That means it will overwrite. So what you see here is line one, right? But what you see on the output is just line two because it's overwritten line one, if that makes sense. Backspace /b. So hello world. Hello, hello B. Oh yeah, the it's backspace. Uh, hmm, X. Right. So those are just so okay. Here's one. Python escape characters. Let's see if we can start this. Oh yeah, here you go. So you can actually just search for this if you want. Um, Python escape characters. Okay. So we're not going to be using this one much, that much, but it's here if you need it. Right? If ever there is a string that you want and it has a single quote and you want that single quote to be printed out, then you have to escape that character so that Python will recognize it. Because remember, the single quote um is a symbol that we will use for strings. That's why you have to escape. But that's what the logic is. Um, all right, so that's basically how to read functions and the syntax and how to use them. What else are we missing? So file, sep, and. All right. Now, any kind of function will have this kind of description similar to this one, right? It has a similar format to this, separated by commas. The parameters or the inputs, we have to use equal signs, and then you have to follow the exact sequence. Now, that's just the rule of thumb. You can actually swap them out if you want, but rule of thumb, again, just to make sure that you're not making any mistakes, that follow the sequence of how it was declared on how you should use it, right? Yeah. So what else? Yeah. So actually, we have keyword arguments. We haven't defined this one, right? So what is a keyword argument? So you start with the name of the input followed by the value of that input. So this is what this looks like. Set This is the key. This is a keyword, and then this is the value. Okay, so this is essentially is a keyword argument, right? The argument here, right, will define that one later, but it's actually really good. Okay? So for now, this is what a keyword argument looks like. So there's a name for a certain value, and then after that is the value itself. Others are not using equal signs. It can be a different symbol if you're using a different language, but usually it's an equal sign. Okay, and yeah, that's it. That's roughly it. So if you can follow this one and you know, if you can follow this one and understand everything that we did, then reading other functions should be easy, even if you were to do it by yourself. So if there are any words again that you don't understand, then just put them somewhere and then try to define them or look for their definition somewhere else and try to see if you can understand it. But usually there's a lot of more words that you don't understand. So just it's a tedious process, but it will get you there. The fun. All right. So now that we know what the function is, we know now that print hi there will just print the hi there. Um, Now we go to a different function. It's now called an input. Now we won't go to the same process again where we have to go to the documentation and then search for how to use it, right? That's gonna be on your part now. Okay. So of course, I'm going to be discussing how to use it basically, but if you want to learn the advanced uses or if there are any other inputs that you can use with it, then you can research that one on your own right now. Okay, so input, let's see here. Hmm. So name equals to input, enter your name. Name, can number, print name. So basically, right, an input. The input function will accept strings. So this string is what will appear on your output, like enter your name, right? This will appear on your output as a way for the program to interact with the user and then ask them for an input. You're asking the user for an input. It's also saved in a variable. I'm just gonna put here name, right? So we're into variables now. Or is it variables? Okay. So after that, we'll see. But for now, if you run this code, right? Let's see. Unterminated string literal. What do we mean by unterminated? Okay. Who can tell me what error I made? Any volunteer? Who can tell me what error I made? Okay, Mark.
You used a single quote, I think.
All right, that's good. So I used a single quote at the beginning, and at the last part, I used a double quote. Right. So that's good. That means you guys were listening. So when I run this program, that means it will put this one on the output. That's what it will do. And then it waits. The program will pause and waits for the user to enter an input here, right? Put input here, any kind of character, it will be considered as something, but we don't know yet. So actually, it will consider it as a string. Again, if you will search for that one, input Python, it's a quick search. It will represent allows user input. So this is something that's lacking because it does not say what it will do with the data. So I'm gonna have to go back to Python reference again and then look for input. Built-in function. Let's see. Converts it into a string, stripping a trailing new line. Trailing new line. So that's another word that we have to define. Trailing new line. And then returns that when EOF is read. EOF is end of file, end of error is raised. So I'm confused with this. Never mind that. Let's skip that word for now. But trailing new line, EOF. Okay. But this is the important part. It converts it into a string. So what does that mean? If you input numbers, you have to find a way to convert that number first into a number data type before you can use it for anything. All right. So, enter your name. There's something here that we need to trailing new line without a trailing new line. So let's try this one out. Trailing new line. So if my guess is correct, trailing new line is some white space here. Nope. If I were to put this one with slash ends, cannot execute. Oh, okay. It's not removing. I don't know why it's not moving. So we can't actually express it with desired output without a trailing new line. It's not responding the way that I anticipated. But, we're not actually printing it like that, but that's okay. Let's say that this is what we are actually asking for. So we're asking for our input, but we don't know where we are going to put that input, right? So this is where variables come in. Okay. So imagine variables as your container, container or a box, right? A box with a name for something, right? So imagine that there's something that you're gonna lead later on, and then if you just put it in any box without a name, then you would have trouble finding where that box is, right? You're gonna have to open all the boxes before you can find the one you need. But if you put a label on that box, that means you can just easily look for that box with that name and get the data that you need. So this is what we are doing with variables. We are putting the result of input with the function to the name variable, right? So how does it do this, right? Like we did not instruct input here to put the value here to the variable, right? Like this is quite advanced. So how do you usually make a variable, right? So the usual way to make a variable is just to declare anything, any kind of name that you want. Let's say this is my first name, and then put an equal sign, and then the data that you want to be stored to that variable. This can be any kind of data or data type. Um, Python will automatically assign it for you. You don't have to think of the data. Like they don't have to match. You don't have to match anything. Just think of the name and then the data that you want to store. So here for me, I'm gonna say Daniel, and then let's say profession equals, and let's say teacher, um, What else? Hobbies, maybe games, something like that. Okay, so how about weight? Oh no, not weight, height. Height. Let's have a number. I don't know the equivalent of 5'4". I'll just say 150. So that's in cm. All right. I think I'm not sure, but this is how you usually declare variables, right? Now, what makes this one different? Okay, we are, it's like we're saying name is equal to the function, right? So the keyword here is the word return. That's the important word here, the return statement. A return statement. So this is the training new line, or what I know here is usually um new line holds at the beginning of the text. So I'm not sure why it didn't run earlier. I'll try to research that one. Again, it's not really that much of an impact to what we're trying to learn here, but it's written there, so it must have some kind of effect. Return statement. Whenever you hear this one, right? I had quite some trouble wrapping this one around my head before. So when you hear the word statement, the word statement, the return statement, what I want you to think is of a try to think of it as you are in a restaurant, right? So you go in the restaurant, you make an order, right? Who comes to your table? The waiter. So the waiter what asks for your order. Your order is the input, right? You are giving input to your uh waiter. The waiter goes back to the back and then the chef will cook it, right? So that's the function doing its thing. It's processing your data. After that, what does the waiter do? It returns to you the final product, right? The output. It returns to you the final product, which is your order, right? So basically, input, right? And then it says here, the function then reads a line from the input, converts it to a string, and returns that. So that means here, at this point, it's asking us, the user, for an input, and then it returns this one where? It returns to here, right? So what do you mean by here? In this location of your code. This is you. This is the customer. This is you. This is where you are making your order, right? And then you enter your order and then it processes it and then it returns it here in this location, right? Basically, what it will look like now, if I were to run this, right, and then I will try something proper like my name, right? Okay, so I enter this one. This is what we see on the output. But to Python, right, after we input Daniel, right, what it will look like is name is equals to the string Daniel. This is what it will look like to Python. So what is it doing? It's um you can try and say that it's changing this line of code into this one and then assign it to the variable. All right. So it's Python is processing the input function first. It's not assigning it yet to the variable. It's processing this one first. And then after it's being processed, what is being returned? What the thing that's being returned is our input, the data. So it's this one. So it will look like this now to Python. And then after that, Python sees nothing else to do rather than to assign it to the variable. So now we have this one here in our variable. So that means we now have access to that, right? So if I were to say print, right? So any object, treat everything in Python as an object. That means a variable can be considered as an object. So if I were to put here the variable name, and then I were to enter it, it will print out my name, supposedly, right? So if I were to enter Daniel, it will output Daniel. See? So now this is saved to that variable, and then I can use that variable however I wish. So if I were to print it out, I can print it out, right? So any kind of input, right? You can ask for their number, their email, those kinds of stuff. And then you can save it to an appropriate variable. So that's essentially what the input will do. Okay, now comes the next point, because what if the uh, input here is something else, more like age, right? Let's say input. How old? Okay, so how would you process it? Because if you were to print this one, let's say, and we're gonna do something like age plus 5, right? And then we're gonna say 5 here just to see if it works. Then it will say it's happening. It will say that there's an error. Why? That it says there's a type error. This is something that you have to get used to, by the way, reading errors. So it says type error can only concatenate string, not int, to string. So str is short for string. Int is a representation of numbers, right? If you remember your basic math, int is short for what? Int is for integers, right? Integers. So integers are the whole numbers from negative to positive something. There was a maximum limit to this one. I forgot what it was, but it's easily searchable. But the point here is that the input will be converted to a string. So we need to find a way to make that string into a number, right? And let's see if that's the next one. Yes. So it's int for integers and float for floating point numbers. Float is the numbers with a decimal point. So int for integers, we have float for decimal points, decimals. Okay. So now you have a way to convert those numbers. So how do we do this, right? There should be an example here. Okay, so we have int, and then okay. So the way that you're using here is kind of weird. Let's do this in a much simpler way, and then go back to this one and try to understand what's happening here. Sorry. Okay. So int is a function, right? And the only thing that it needs is a string input that needs to be converted uh into a integer equivalent. Okay, that's the default way of how it works. There are other ways of using the int function, but again, you guys, it's up to you guys to look for that. But if I remember correctly, we're gonna discuss that one as well somewhere down the road. Other uses of int. But for now, the way that you use that one is you pass in a string, and then what's happening with my Jupyter notebook? It keeps on. Yeah. Okay, so if we say by print, right? So we say that it converts a string to a number. So if we say int, and then this is a function, right? So it has open and close parentheses. And then if I were to add strings like one, this is a string of one, and then int again, and then this is a string of three. So what the output will be now is 4, because the string 1 and the string 3 is not anymore a string, but a number that's converted because of the int function, right? Now, the int function will what? It will return the equivalent, the number equivalent of that string. So to Python, it will look something like this now. Okay. So I always imagine this one whenever I hear the return statement, like what would it look like to the language, to the programming language after it's been returned. So it will look like an ordinary 1 plus 3. That is what it will look like to Python. Okay. So after that, it processes that one and then prints it out. Okay. Again, it starts from the inside, okay, and then goes outside. So it processes this one first, processes this one again, processes the whole thing, evaluates it, and then before passing it to the print function and then printing it out here. Inside, outside. That's how Python works. Okay. So, what does this mean? That means that mm, as long as we pass a string inside of int, it will be converted into a integer, right? So if we go back to our problem here, let's see, age input, how old are you? Now, if you remember input, what does the input returns? The input returns a string. So basically, if we pass that one directly to an int, that's why we put int here, and we pass this one, this entire thing as an input to int, this will work because if the input is done, right? This will become what? This will become a string, and then that string will then be converted into an int, and then that number will now be saved as a variable age. And then now we can process it as regular mathematics. So if we were to run this one and say 10, enter, and now it's being processed properly. Okay, so don't be confused with this one. Functions within functions, function declaration again within another function. Okay. So the main point here is that if you understand the return, okay, um, what is being, I don't, is there a better word for return? What is the output? The output, um, the output being placed to where the function was called there. Function was called. So this is where you are calling the function. You are declaring the function, right? Using the function. And then this is also where it will return. Okay. Where you're calling it, that's where it will return as well. Whatever that return thing is. It can be a database or it can be as simple as a name, right? A password, it doesn't matter where you are calling that function, that is where it will return to. And then depending on that, um, it will serve as an input again to another function here. All right. So you're just making it a bit simpler by doing it like this. Of course, you can make it a bit harder and then do it like this. Like if I were to say age and then no, wait. If I were to say age is equals to input, right? And then I will ask, how old are you? Okay, so that you won't get confused, and then you can say um age none, this equals to int. Sorry, I'm using fix it. Int, and then you pass in age here, and then that's the time where you say age num plus 5. So I hope everyone gets the idea here. I don't know what's happening with um, hmm, all right. So if I put 10 here, it has the same output, see, but I just added an extra step, an extra line. Okay, so this has only 2 lines. Where's it? This one. This one only has, what's happening? There you go. So this one has 2 lines, this one has 3 lines, but this is a bit easier to understand than this one. But as you get better, you'll start doing things like this. Okay. What else? Mm. The same thing goes for float. You're just going to be using numbers with decimals. So the same thing with int and how they work. Okay. I have a question. What problem do you think you will encounter using this code? Any of these two. What problem do you think you will encounter using this code at this point? So anyone? Sorry. Any volunteer? So just this one and this one for 46 and this one. These two. Yes, Sir Mark.
Could it be that if the user were to input something other than a number, let's say a
Yes,
string?
correct. So we did not take into account that the user would be I don't know, 1 year old, right? So what if they input something else? So what do you think will happen? Let's try this one. If you were to input like text to you, then I were to enter this one, it will of course enter an error, a value error, invalid literal for int with base 10 b. So int is using the default of base 10. So with this, you can kind of guess that you can modify int later on with different bases because we have different number systems, right? We don't just have base 10, we have base 8, base 16, different kinds of number systems. So by default, it's using the integer, so that's base 10, right? So that's what the integer number is, right? It's 0 to 9, not 1 to 10. It's 0 to 9, just to make it clear. Um, yeah, I think that's it. So we did not take that into account. And how do we do that? Um, Usually you can restrict users, but we're not really at that point right now because as data scientists, we're not really um asking users for data that is directly, you know, transferred to our program. So what we usually do is we collect the data first, right? So that's whether via Google Forms or Google Surveys. That's the usual way to do it. And then what you will do is uh, with those apps, there's you can actually set it up that you will only accept numbers here, you will only accept dates, but you can also add more restrictions here on your program that you should check if they are all numbers. But that's actually part of the data process that we're gonna do. We're gonna check all the data if they are valid. If there are invalid data, we're gonna remove those rows or columns that we don't want, and then make it easier for our model to actually predict outcomes, right? Okay, so I hope you're excited for that one. Next is, let's see. Again, if you master this first part, the rest of the functions, whatever they may be, will be a bit easier. Um, where am I? Input. Oh yeah, int. Okay, this is just a review. Yes, prompt int. All right, next. We can then run Python programs with IDLEs. We don't really need this one. Essentially before Anaconda, we had to use a different IDE. This is an IDE. It's short for um IDE is short for Integrated Development Environment. Integrated Development Environment. This is not just limited to coding. There are other IDEs for different purposes, but this is an IDE. Jupyter Notebook is an IDE. If you want some other IDEs that you can check out, there is Visual Studio Code, which is what I use, but this is kind of more difficult for beginners. That's why I don't recommend this one for starters because there's too many things happening at the same time. But it's great if you get, more experience because it's almost a de facto thing that we use. But for data science, what they usually use is Jupyter Notebook at the beginning, and then if they want more power or their model gets bigger and bigger, usually they go to better IDEs, but that's in the future. For now, let's focus first on um, Jupyter Notebook. Anyway, what you will learn in Jupyter Notebook, you can apply it anywhere. So IDE is irrelevant. It doesn't matter what you're using. Okay. I'm just showing you guys the other alternatives. So that's Visual Studio. Others prefer Selenium. Forgot the name of the other one. Brackets. Is it brackets? IDE. Yeah, it's this one. I'm not sure if this is still available. Yeah, okay. So others prefer this one. There are plenty of other IDEs out there. Again, it's not the IDE, it's the program that they're making. That's important. Um, why did I arrive to that? I forgot what I was trying to make a point. Um, let's go back here. Oh yeah, it's because of the Pi extension. Because when you make a program in other IDEs, what you will get is a file that ends with a .py extension. That's short for Python. So any IDE that can run a Python file, you can just open it up there and then you can see it. But here in Jupyter Notebook, what you end up here is the IPYNB, all right? And that is um a file type for Jupyter Notebook, right? So I figured NB is for notebook, Python notebook. So yeah, it has a different file type than what is discussed here. Does this mean that you cannot open this one in other IDEs? No, you can open this one in other IDEs as well. In fact, you can open this one in browser. It will just look weird. Let me try and show this one to you. Just so that you guys can see that it's not limiting us, right? Okay, it's using the other one. Let's see, open this one, choose the app. Let's see. Okay, let me try and just drag this one. Ah, there we go. Okay, so if you open the file directly, this is what it will look like. Okay, this is the source code for a Jupyter Notebook file. This is what it looks like. And it looks weird, right? But if you take a look closely, this is what I was writing. So data types, string, C, slash n, objects, slash n. There's an enter key between this and this, right? And you can relate this one here. So there's an enter key here. It's invisible, but if you take a look at the raw data, you will see the slash n's. See? Well, what do you notice? Almost everything is in string format, right? And there are some other data types here as well that you haven't learned yet, but that's okay. We'll go to that soon. Again, we're not limited to the IDE. You can open the file anywhere that you want, even in Notepad. And yeah, that's it. What else? I think that's it. For the libraries, we're not using them right now. We'll start using libraries when you get to finish the basics of Python, basics and basic to mid, actually. And then after that, we start with web scraping, where you deal with other libraries and how to get data from the web. Next is, what's the next part? So this is a format of an IDLE window. Just to show you what this looks like. Let's see. All right, so my version here is different. This is 3.6. What I have here is 3.13. So I'm gonna show you what this one looks like. Share. All right, so this is what you see now. Again, this is the shell, right? And this is in direct Uh, I'm talking directly to the kernel to this one and basically the computer itself. So if I were to say print and then hello, everything that works with what you learned earlier works here as well. See, print hello. If I were to say name is equals to Daniel and then print out name again here, it will work. If I say print and then how did that come out early? Okay. Something came out earlier, like kind of suggestion or a help, sort of. It's not coming out again. Never mind. But essentially, what you learned earlier can be applied here as well. Again, this is not really that practical because I think the IDLE you can't output graphs. So um in Jupyter Notebook, you can actually output graphs, which is what we need really. Next is it's the same thing. We already discussed this one earlier. Syntax errors, yes, you're gonna be encountering a lot of errors. The trick to reading errors is to know where that occurred first. So here right now, if you want, you can go to settings and then click on view and show line numbers. This will allow you to see the numbers, right? And if there are any errors, like say, for example, I want to like delete this one, will produce an error. It will say in 50 line 1. So it will say it occurred in line 1. And then the specific error that occurred. Okay, right now it seems simple. The error is simple, say in rand syntax. But later on, when you start using libraries, it can get more complicated and a very long error code because it will show you each and every part the error occurred, even in the libraries. So you won't have to read all the errors. You're just gonna read the important part. where it occurred, and then analyze your code there. You don't have to look at the library because you did not make the library. Someone else made that for us, and all we have to do is use it and pass it the data that it needs. Okay. Um, okay, so we have some things here that we haven't defined yet. That's okay. What else? Syntax. So this is an error example. Yep. Fundamental ideas. We're done with this. Done. High level. Then fast. Terminals. Yep. And that's it. This is actually the end of the chapter. So let's see if I forgot anything else. How about you guys? Do you have any question with the thing we have learned? The things we have learned? So the important point again was the function, how to read function, the documentation, and other options aside from the documentation, right? The easier one, the complete one. Yeah. Any question or clarifications? All right, so it seems that there are no questions, so that's good. That means if I were to have a quiz, everyone should get perfect, right? Since everyone understood the lesson, so that's great. Actually, I don't have any exercises here for now. I'm also sure not everyone has installed Anaconda yet. So I guess we'll start having exercises next week. Anyway, we just learned how many functions today? Print, int, float, input. That's it. Four. Four of the most basic functions we know. We also know variables, keyword arguments, and the most important one is how to read the function, how to read the definition of the function and the syntax. All right, so I guess we can end early for today. If you guys have no questions, I will upload the recording as soon as I can. I will also upload the PowerPoint that you are viewing here to the LMS. And along with this notebook, I will upload this one to the LMS as well. If you want to open this one, all you have to do is open Jupyter Notebook and look for the file and then just double click it. Okay, just double click it and then it will just open up automatically. So the notes will look like this one because it's in Markdown. Again, we don't need to know Markdown. It's just a way of formatting text. As you can see, it's um a bit cleaner now, right? So that's actually one of the main things that makes Jupyter Notebook great. It's explanation code, and then some graphs if you want. So you can kind of like guide the reader on how you want to present the work. So this is important when you want to present projects or research. It's like that one. So you start with explanations and then the code, because all the cells here, I did not explain this one, all the cells here are actually connected, right? So if I were to say like, if I were to declare um sport, for example, and then I were to say basketball, right? And I were to run this code. This variable is essentially stored somewhere, but it's actually connected to all the other cells. So if I were to have another cell here and I were to say print and then sport, it will still print the same thing. So you can separate different cells, and then in between them you can add explanations in Markdown, right? So you can say if you use three hashtags and then say explanation, it will look like this if you run it. So it's like in bold, but in that format. So if you want to learn more, You can just search for Markdown. There's a lot of it in Google. It's very easy to learn. And the most common thing that I use is just the dash. It's for creating bullet points, and then the hashtags for creating bold uh text like this. That's the usual thing I use. All right. Other than that, I think there's nothing else. Next week, I think it will be Mom Shy, because usually yeah, it's supposed to be Mom Shy that will handle session 1 to 5. I will handle session 6 to 10. But now, since she was absent, that's why I was subbing for her. But next week, I think she will be your instructor for session 2. All right. So that's it. Um, I'll stop the recording and I'll see you guys on session 6. Goodbye.
Thanks,
Thank you,
Daniel.
sir. Thank
Goodbye.
you.
You're welcome.
Bye, sir.
Goodbye.